Greetings, guys. This is just a walkthrough of this midterm review. So that's the key to that thing. Okay, first thing, simplify the radical expression. Okay, to simplify a radical, remember, I need to write this out as its prime factors. So 32 is the same as 2 times 16, and 16 is the same as 2 times 8, and 8 is the same as 2 times 4, and 4 is the same as 2 times 2. So as I see this, guys, I've seen a lot of y'all that are adding numbers like 16 plus 16. Remember, these are multiplied, and I'm looking at the ends of every one of those branches. So this is 2 times 2 times 2 times 2 times 2. So I write that 2 times 2 times 2 times 2 times 2. Okay, now look at your index. The index here is a 2. So it tells me I'm looking for groups that are too big. So I see a group of 2 things here. And every time I see a group, I pull one out. So that group's done. I see a group of 2. So I pull another one out. That's done. And there are no more groups of 2, but there is left underneath the radical that 2 right there. Okay? So every time I make a group, pull the factor out. If it's left, leave it alone underneath the radical and then write it out. Simplify the outside. 2 times 2 is 4. And the inside is the square root of 2, and that's it. Okay. The same thing goes for here. Okay? Now I've got the negative 4 on the outside. But let's look at this. 24. Well, 24 is 4 times 6. And 4 is 2 times 2. And 6 is 3 times 2. So there's my ends. 2 times 2 times 3 times 2. So 2 times 2 times 3 times 2. And then I've got x cubed. That means I've got 1, 2, 3 x's and 2 y's. 1, 2 y's. Okay. Now, the negative 4 is already on the outside, so it's still there. Now, the index is 2, so I'm looking for groups of 2. There's a group of 2, so I'm going to be able to pull a 2 out. That's gone. 3, 2. Here's a group of 2 x's, so I'll be able to pull an x out. Here's a group of 2 y's, so I'll be able to pull a y out. There are no other groups of 2 in here, so what's left underneath is 3 times 2 times the x there. Okay, simplify the outside. 4 times 2, that's a negative 8 because that's a negative 4. xy. And then on the inside, 3 times 2 is 6. So I've got 6x. Cool. Okay, so there's my answer there. Okay, rewrite in exponential form. And look here, this is rewrite the following expression in radical form. So this is exponential, this is radical. So I need to rewrite this as an exponential. So I take the thing underneath, this becomes a power, and then this becomes a denominator of the power. So p to the 5/4. Okay? This is going backwards. So I'm going to have a radical. The 5r in parentheses goes there. But wait. See the negative? The negative exponent says it's all underneath a 1. So I got to think the negative puts under 1. The 7 here becomes the index, just like the 4 became the index there. And then this 6 becomes a power. That's it. So with a negative exponent, make sure you throw it under a 1. Okay, simplify this. Okay, this is like what a lot of y'all have done in a quiz. I've got to go 5 to the power of 3, and then I have to go y cubed to the power of 3. Okay? 5 to the power of 3 is not 15. That's 5 times 3. This is 5 to the power of 3, which means 5 times 5 times 5, which is 125. And then this, I have a power to a power, so I multiply those. 3 times 3 is 9. Okay? Now this. These have different indexes. The only thing we did with different indexes is to write them as exponentials, kind of like what we did up here. The top number, the power, that's a power, and this index here, it's 2 in this case, becomes the index. So this is power of 1/2, and this is times x to the power of 1 over the 5. Now I have a rule that says if I'm multiplying powers, I add their exponents. So I have to figure out what 1/2 plus 1/5 is. And so I type that in my calculator, and I get 7/12. Okay, and I got that from just typing my calculator off here. Here, let me show you. 1/2 plus 1/5. Oh, I lied, not 7/12. 7/10. I thought it was 7/12. It's 7/10. Duh, because 10 is the common denominator. Okay, so I don't expect you to do that in your head. I do expect you to be able to type in the calculator or do it in your head. Okay, on the back page, rewrite it in exponential form. Okay, and this is rewrite in radical form. So these are kind of going backwards of each other. Exponential form, I take the c, top number is the power. This becomes the denominator, so c to the power of 9/4. Now check this out. See how it's under a 1? That means there's going to be a negative exponent. See the parentheses there? I need to leave them there. So I've got 9p. It's a negative power since it's underneath a 1. This top number, the 3 becomes the power, or the top of the power. The 4 becomes the denominator. So negative exponent because it's under a 1. 3 because that's the power. 4 because that's the index. T to the power of 5/6. So radical is going to have a radical sign, and the base is going to be underneath. 5, that's a power, and 6 is the index. Okay, now if you had this, that's the same thing. The 6th root of t to the 5th. Okay, parentheses around the 6x, which means I'm going to have parentheses around the 6x out here, and there's going to be a radical symbol over it. 3, that's the top, becomes a power. 4, the bottom, becomes the index. That's it. All these are rewriting. Don't miss them. They're easy peasy stuffs, okay? Now, let's look at the rest of this. Okay, 11. Simplify. Okay, so off to the side for a second. 60. It's the same as 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So I've got 2 times 3 times 2 times 5. And then r to the 5th. That means there's 1, 2, 3, 4, 5 r's. In my index up here, it's invisible, so it's a 2. So looking for groups of 2. There's an r. I can pull that out. There's another r, a pair of r's. I can pull that out. So that makes r to the 2nd, since it's r times r. And here's a power of 2's, a pair of 2's rather. So I pull a 2 out. So the 2 r's and the 2 got pulled out, and left underneath, I've got this 3, this 5, and that r. So simplify this. 2r squared, that's what's on the outside, and I've got it on the inside, 3 times 5, 15r. Cool. Okay. Next problem. 7's already out there. Sorry, I'm yawning here. 120. Come off to the side. 120 is the same as 12 times 10. 10 is the same as 2 times 5. 12 is the same as 2 times 6. 6 is 2 times 3. So all in all, there's my ends. 2 times 3 times 2 times 2 times 5. X cubed, so that's 3 x's and a y. Looking for groups. Okay, there's a pair of 2's. There's a pair of x's. Is that it? So I've got 7 times the 2 that I'm able to pull out times the x that I'm going to be able to pull out. There's a 2, a 3, a 5, and an x and a y. That's all there is to it. So left on the inside, I've got 2 times 3 times 5 times x, y. Okay, on the outside, 7 times 2 is 14. Always simplify x, because the x is right there. On the inside, I've got 2 times 3 is 6 times 5 is 30, x, y. There it is. Okay, so once you've pulled things out, simplify the inside, simplify the outside. Okay. Moving on. Here. Okay, this is all about exponent rules. There's a lot of things I can do first, but first I can put that exponent there and there. Now, when I have a power to a power, I multiply the exponents. So this is r to the power of 3 times negative 1/5. Well, 3 times negative 1/5 is negative 3/5. And I've got y to the 5 times negative 1/5. 5 times negative 1/5 is negative 1. Okay. So that's already done now, but I can't have negative exponents. But negative exponents, I just throw them underneath the 1. So this is r to the power of positive 3/5 and y to the power of 1. And that's it. No more negative exponents. The operations are done. That's as simple as I get. Okay. Now, here, I'm going to add these. So w to the power of, what's 4/5 plus 1/2? I don't know. So 4/5 plus, 4/5 plus 1/2 gives me 13/10. So because these are multiplied, I'm going to add these, and I get 13/10. And 2/3 minus 4/3. I can do that. That's negative 2/3, right? 2/3 minus 4/3 gives me negative 2/3. The negative there tells me it's on the bottom. So r to the power of 2/3 on the bottom. There it is. I just combined the w's, combined the r's. The r's happen to have a negative exponent in the end, so that got thrown to the bottom. Okay. Moving on. Okay, so 15 and 16 are about subtracting and adding radicals. Remember, I can add and subtract radicals if their indexes are the same. So here's a cubed root and a cubed root. Or here there's square root, square root, square root. So I can add all these and these if they have the same index and the radicand. 2 and it's not the same as 54. 2 is not the same as 8 or 12. So I've got to try and simplify first, and then maybe I can add them. So here, 2. I can't do anything with 2. So this is just 3 times the cubed root of 2. But 54 breaks down into 2 times 27. And 27 is 3 times 9. And 9 is 3 times 3. So this is minus the cubed root of 2 times 3 times 3 times 3. Well, there's 3 3's. See it? Which means I can pull it out. So I've got 3 times the cubed root of 2 here and there, minus 3, because I pulled it out, times the cubed root of the 2 that's left there. Well, that makes nothing, because 3, now they're the same index and the same radicand. Square root of 2, square root of 2. 3 squared to 2 minus 3 squared to 2 is 0 squared to 2, so it's just 0. Okay. Now, let's look at this one. 2 squared to 2. 2 I can't break down, so that one's done. 8. 8 is the same as 4 times 2, and 4 breaks down to 2 times 2. And I'm looking for pairs. There's a pair of 2's right there. So minus 2 times 2, the 2 that I'm going to pull out, times the square root of, there's the 2 that's left in there, plus 3 times square root of 12. Well, 12 is the same as 4 times 3, and 4 is 2 times 2. There's a pair of 2's I can pull out. And that 3 is left underneath. So here I've got 2 square roots of 2 minus 2 times 2 is 4 square roots of 2 plus 3 times 2 is 6 square roots of 3. These are alike. 2 minus 4 is negative 2 square roots of 2 plus 6 square roots of 3. And there I'm done because these are not alike. I can't combine them. Okay? Okay. Now, multiplying. 17 and 18 deal with multiplying. Now, multiplying radicals, I can multiply the stuff underneath the radical if they have the same index. So 2 times the square root of 12 times the square root of 6. I'm going to distribute this through. Square root of 6 times square root of 12, the 2 is still there. 12 times 6 is 72. 6 times that. So minus 6, because there's a 1 there. 6. Oh, nope. I'm lying. I'm lying. I'm not seeing things. Or I am seeing things, however you think about it. There's a 1 there and a 1 there. 1 times 1 is 1. And then square root of 6 times square root of 6 is square root of 36. Okay? Now, square root of 36. Let's think. 36 is the same as 6 times 6. There's a pair. So I can pull it out and nothing's left. 72. 72 is the same as 2 times 36. 36, I already done that. That's the same as 6 times 6. I can pull that out. So I've got the 2 that's out there already, the 6 that I'm able to pull out, and the square root of the 2 that's left there. So 2 times 6 is 12. Square roots of 2 minus 6. I can't combine them because that has a square root of 2 and this doesn't. So that's done. Okay, now let's look at this. A couple problems left. I've got 4 square roots of 6 minus 7 times 4 square roots of 6 plus 7. I have to distribute this through. If I multiply this times this, 4 times 4 is 16. The square root of 6 times the square root of 6, that's the same as the square root of 36. Now, I already found over here the square root of 36 is 6. So this is just 16 times 6. 4 square roots of 6 times 7. 4 times 7 is 28. Square roots of 6. Negative 7 times 4 square roots of 6 is negative 28. Square roots of 6. That's gone because they cancel each other. And I've got negative 7 times positive 7 as my last distribution. That's a negative 49. So 16 times 6 minus 49. 16 times 6 minus 49. I type that in my calculator and I get 47. Okay? Last problem. Calculate the perimeter of the rectangle. Timeout. If I have a rectangle and I need to do its perimeter, I'm going to add up all 4 sides. And this says, here's my sides. I've got 7 minus the square root of 6. And the other side has to be 4 plus the square root of 6. And because those are the sides, I know this side is 4 plus the square root of 6 because it's the same as that one. And this is 7 minus the square root of 6. Now, if I add all these together, check out what happens. 7 minus the square root of 6 plus 4 plus the square root of 6 plus 7 minus the square root of 6 plus 4 plus the square root of 6. Check out this. See what happens with this negative square root of 6 and positive square root of 6? They're going to cancel. Negative square root of 6, positive square root of 6, they're going to cancel. And all I have left is 7 plus 4 plus 7 plus 4. 7 plus 4 plus 7 plus 4 gives me 22. Guys, that's the whole test in a nutshell. Use that and your homework and your notes to study, and I'll see you test time. Bye-bye.